Kiss man.
Good day. Welcome back to our YouTube channel. So if you're new here, welcome. My name is Stifler, and I hope you are going to enjoy this content with me here, and I also hope that you're going to subscribe after watching this. So today we are going to deal with work energy and power. So before embarking on this journey, let's first revisit the topic in grade 10 that we dealt with on mechanical energies. So this first part will be just the introduction of work energy and power. We're just going to be talking about mechanical energies, and then we'll see what happens after. So let's get straight to it. So in grade 10, you learned a lot about mechanical energy. So there are a lot of energies in this universe. There's electrical energy, there's chemical energy, and so on and so on. But now we're interested in the mechanical energies, right? So first we'll talk about the kinetic energy. So what is kinetic energy? So kinetic energy is the energy an object has due to its motion, due to how the object is moving. So that is kinetic energy. So it is measured in joules. So to calculate kinetic energy of any object, we can just say EK, we represent kinetic energy by EK, and it is equal to half mv squared, where m is the mass of the object in kgs, and then v is the velocity of the object in meters per second. So we measure EK in joules. This is the energy an object has due to its motion. And we also talked about gravitational potential energy. So gravitational potential energy is the energy an object has due to its position in the gravitational field. And this is represented by EP, and it is also measured in joules. And EP is equal to mgh, where m is the mass of the object in kg, and g is the gravitational acceleration, which is 9.8 meters per square second, and h is the height that this object is at. That is gravitational potential energy. And also we're interested in knowing what is mechanical energy. So mechanical energy, it is the sum of kinetic energy and potential energy of an object. So this is EM being equal to EK plus EP. So these energies, we dealt with them in grade 10, and mostly with these two laws that we learned in grade 10. So let's talk about the laws that we learned in grade 10. In grade 10, we learned these two laws. So the first law was the law of conservation of energy. The law of conservation of energy. Energy cannot be created or destroyed. It can be transformed from one form to the other. So we cannot create energy or destroy it. We can transform it from one form to the other. Just like for an example, if you're having a generator, right? A generator can change the kinetic energy into electrical energy. Just like in the batteries changes the chemical energy stored in the batteries into electrical energy. So energy can be transformed from one form to the other, or it can also be transferred from one object to the other. Just think about the heat energy. You light up the stove, energy is formed there, and it can be transferred from the stove to a pot, and the pot can start to get hot. So that is the transfer of energy from one object to the other. So we cannot create energy or destroy energy. We can transform from one form to the other, or transfer from one object to the other. And also talked about the law of conservation of mechanical energy. The mechanical energy of an isolated system is conserved. The mechanical energy of an isolated system is conserved. So an isolated system, we know that this is a system where there are no any external forces. So there are no external forces in this. There is only gravitational force at most, right? So most of the systems that are isolated, we know that only gravitational force is acting on those objects. So this is the mechanical, the conservation of mechanical energy. So this means that EM initial can be equals to EM final, no matter the situation. The mechanical energy is conserved. And you know that the mechanical energy, it is the same as, so this is EK initial plus EP initial will be equals to EK final plus EP final. The mechanical energy remains conserved once it is an isolated system. So there are no any other factors acting, only Fg is acting. So let's see how we're using this law in grade 10. So let's see the situation that we're having there. They said 80 kg object slips, so anything that slips, the initial velocity is 0 there, from point A, which is 3 meters high, to point B on the ground. Ignore effects of air friction or any other external forces. And the question is, what is the velocity of the object when it is at point B? So we need the velocity of this object at point B. Since we know that this is an isolated system, now it will only mean that our mechanical energy is conserved. So this means that our EM initial is equal to our EM final. The mechanical energy is conserved there. So we can expand this formula to say EK initial plus EP initial is equal to EK final plus EP final. And you can expand further again. So this is half mv squared initial plus mgh initial is equal to half mv squared final plus mgh final. So now let's substitute whatever that we're having. So this is half, and the mass there is 80. The velocity there initially was 0 squared plus the mass again being 80. Gravitational acceleration 9.8, and our height is 3 there at point A, right? So initial is at point A. So whatever that it is, this side it is talking about point A. So at point B, this would be half the mass, which is 80, and the velocity we are trying to find that, plus the mass again, which is 80, gravitational acceleration 9.8, and our height here at the ground level, it is 0. So obviously this will give us 0, and also this will give us 0. So now we are going to have this inside the calculator. We are going to have 2352 being equals to 40v squared final. So we can divide both sides by 40 and also by 40 there. So it means that our v squared final can become 58.8, and square root there, square root there. So v final can become 7.67 meters per second. This is our final velocity at point B. So it means that the velocity at that point, it is 7.67. This is how we used to calculate energies, velocities, and also the height of buildings when you are having an isolated system. So now, since you are in grade 12 now, we are interested in knowing how are we going to calculate the energy if there are external forces now. Because this only happened when we didn't have any external forces. It was an isolated system. So now, how are we going to apply when we are dealing with the energies, when we are having external forces acting on objects now? So to understand how we're doing this, join me in my next session on work, energy, and power. I hope you enjoyed this recap, and I also hope that you subscribe to our channel. I'll see you on the next one. Have a lovely day.